Hello everyone. So today I'm going to be quickly guiding you through our Phoretix 1D gel densitometry software. Now, some of you may have used TotalLab 100, CLIQS, ImageQuant, GelQuant, some of those previous versions of software that we've used before for your gel densitometry needs. But Phoretix 1D is the latest version of software that we produce for gel densitometry. It's compatible with Windows, Mac, and Linux. It's fully supported up to the latest version of Mac OS. I think that's Big Sur. Worked on M1, M2, M3, M4 silicon from Apple and is tested on Windows 11. And of course comes in a 21 CFR and GMP compliant version for use in the pharmaceutical industry. Now, I'm not going to be going through that. I'm just going to be showing you the stock version here, which is what you would use in a regulated environment with an additional layer on top, but the underlying software is still the same. So first thing we want to do is obviously open up the gel that we want to perform densitometry on. So I'm just going to grab a demo image that we've got here and show you how we're going to start quantifying this and how we're going to get some measurements from it. So this is actually a multi-channel image that we've got here. I'm not going to really bother with the multi-channelness of it. I'm not going to perform normalization or anything, but I'll talk you briefly through the options that are available in the software. So first of all, this is the image setup view. It allows you to visualize your data and observe, for example, any areas of saturation. So we can see here this orange highlighted area is a saturated band. Saturated band is basically when the intensity of a band has reached the limit of detection, the upper limit of detection of the piece of equipment that you've used to perform your imaging. So be it a scanner, gel doc device, even if you're taking a picture on your phone. It means that if we did try to perform densitometry on these different bands, the results that we get are not going to be, how do we say, reliable. Because they could be, let's say our piece of equipment has a cutoff of 10,000 units. This section could be 10,001 units in intensity, or it could be 50,000. We can't accurately get a measurement for these saturated areas. So the point of this view is that we're able to see saturated areas and discount them from our analysis, make sure that we don't put any trust or faith essentially in bad data. However, we can see that the rest of our bands, some of this area is orange here, but the rest of our bands seem to be fine. So first step here within the image view is basically just to see that the data in your image is being interpreted correctly. I've got peaks instead of troughs. And I know where my saturated bands are, so I can discount them from my analysis. Now, there's nothing I can do at the software level to unsaturate these bands or desaturate these bands. I would have to go back to basically a shorter exposure time for my next gel, or if I had captured multiple images at different exposure times, go back to an earlier point in time when these bands were not at the upper limit of detection for the device, and then go and perform densitometry there. Obviously, the changes would ideally be relative, theoretically be relative. So quantifying a earlier time point shouldn't really lose you any information. What you may lose is a certain sensitivity on the bottom end. And that's kind of a bigger issue that I'm not going to go into on this video. So once I've performed that kind of visual lookup to check if I've got any bad data within my image, I can go ahead and perform automatic lane detection, or I can perform manual lane detection by coming in and telling my software that I want 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I want 20 lanes. So I can come in and draw my box for my image. Start telling the software where my data is. Then I can run through band detection. Now I'm doing this quite quickly because I've got other videos that go into each section of this much more deeply. If you're interested, or if you're stuck using the software on maybe you're not confident in your lane detection or how you've edited your lane box, things like that, I've got separate videos for all of these. This is just an overview at this point, so surface level. Next, I can perform my background removal, and I can perform that on a lane by lane basis, so I can have different background removal techniques and strengths depending on the lane that I'm working on, or I can also have it variable by channel as well. So I can have different channels with different stains, with different kind of non-specific binding. I can accommodate for that using different strengths of background removal. So in terms of background correction methods, I've got rolling ball, and I can change the settings of that. I can see in real time how the settings that I'm changing are changing the data that I'm looking at. Where are we setting the boundary for our peaks and things like that for the bottom of our background? Basically, what data is going to be subtracted. If I click this box, I can see how that flattens out my data by subtracting all of the noise in the background. Got rubber band. I've got constant value, profile minimum, image rectangle. Again, I've got separate videos going into all of this in much greater detail. So if you want to check those out, check out the playlist for Phoretix 1D, and you'll be able to find all that information there. And we've got fully manual background subtraction as well for people with very uneven background levels that the other methods simply cannot cope with, and you want to go in for something manual. Next, we can perform our band detection. Now, I've just hit the defaults here, so it's done okay actually, considering I've not messed with it, but there are obviously some channels here that it's not done very well on. I can add some bands in manually if I want, just by left-clicking here, or remove some by just right-clicking and dragging there. But you'll start to see as soon as we start getting bands, we start getting band measurements in this table. Now we've got things like volume, raw volumes. That's obviously volume without the back. That's volume with the background added on as well. The volume is with the background subtracted volume. We've got the number of bands. We've got the band volume, whether it was, what the background removal method we used was. But we've also got, if you click this button here, we can turn on or off all of these different measurements to only focus on the measurements that we care about. If you want to see everything, you can see everything. But if you're only interested in, say, raw volume or normalized volume or kind of background corrected volume, you can turn that on or off, so that's all that you see. If we come down to molecular weight, we can start adding on our different ladders. So we can add in one of our commercial ladders, for example, and then we can start getting measurements for molecular weight calibration. So estimates of molecular weight of our band, whether that be in kilodaltons for proteins or base pairs for DNA or RNA. We support all of those within the ladder section. Again, I said I wasn't going to talk about normalization, but that just allows you to normalize your data to other bands or other channels within the image if you're using a multi-channel image. Quantity calibration allows you to tell the software if you've got some bands of kind of a known concentration or a known kind of quantity mass. You can then extrapolate based on intensity, based on the densitometry of your bands, the mass of every band. So, for example, if I created a calibration curve with 3 points on, if I just select a single channel here, but if I add this band, and this band, and let's say I had 100 picograms of protein here, 50 picograms of protein here, 20 picograms of protein here, I would set my curve fitting type. I'll just leave it as log for now. And then I can come along and change my lane table to a band table. So now I get band information. We can now see the calibrated volume. Now it's kind of all over the place because these aren't real measurements, but I could say in this band there is 19.98 picograms of protein. And you can do the same with base pairs in DNA or RNA. But you can perform a quantitative analysis using the quantity cal on your gel image there. And then of course we can come through to the results section. And from here we can choose what we want to export into our report, choose what we want to export into a CSV, and basically choose what we want to display, if we want to copy it to clipboard and things like that. So we've got full access to all of our data. We can turn on, see the raw volume, normalized volume, band percentage, delay percentage. We can turn on the volume unit, which we haven't given it any volume unit, so everything is intensity here, basically. Lane names, if we've entered any, things like that. So we can build up and customize the data that we're showing on a report using this results section, and then come through and click our generate PDF report or generate our CSV and add on a few different options here. And we can choose which lanes and which bands we want to export results for. So if you're only interested in a couple of your lanes, that's absolutely fine. We can do a report on just a couple of lanes rather than having to do the whole thing. But you can see here is all of our raw data here for you to work from, work back from, validate, check in-house. And we do also support calibration of gels. So a lot of people performing, gel densitometry in pharma industry will be using calibrated gels, so they'll be using a step wedge. We do support that as well. So we support images that already have their own calibration information in the metadata, or within our 21 CFR or GMP solution, we have a full image calibration tool as well. So you can use images that you've got of a step wedge to then calibrate your images to then use that in a calibrated fashion for, calibrated gel densitometry. So I hope this is useful for you. I hope this will kind of bring you towards the direction of investigating Phoretix 1D further if gel densitometry is something that you're routinely performing on site. If you've got any questions, please drop a comment below. We always check the YouTube channel, or reach out to us directly on our website, and you can get a free trial of Phoretix 1D to see how it works with your images in your own lab with the links in the description below, or just go to our website and find it from there. But yeah, if you've got any questions, please reach out and we'll be happy to discuss your needs.